then they make this nice bar chart. So they say the thinking process helps the most with like research and analysis tasks, and then it seems to help the least with creative writing. All right, welcome everybody to Archive Dives with Oxen AI. Today we have a fun paper called Thinking LLMs, General Instruction Following with Thought Generation. This is by the team at Meta AI, and we've done a couple papers from this team in the past. I always really love Jason Weston here. He's like a OG NLP guy. I've been training large neural networks for a while now, so anytime he releases a paper, I love to check it out. And this paper specifically is kind of Meta's response to the O1 work by OpenAI. And it's all about generating thoughts and thinking deeply about how we generate thoughts with LLMs. And to get a concrete sense of what this means and why it's a hard problem, they actually have a pretty funny example at the end of the paper of an LLM overthinking. But you can kind of see the whole thought process of the LLM overthinking, and we'll go through this example to make it concrete. But first, these LLMs this LLM in this paper is going to be trained to list its internal thoughts, so like its internal dialogue. Then it's going to draft a response, then it's going to evaluate its draft, and then finally respond with the answer. And you can see the entire process and where it kind of goes awry in this example from the appendix. So the instruction here is make one line Python code to get a list of primes from 1 to 200, use a lambda function, and list comprehension. So the LLM outputs its internal thoughts and analyzes the query. It makes a draft response, which is its initial attempt, which is actually the correct solution here. It then evaluates the code that it wrote above and says, this works, but it isn't that efficient. And then it rewrites the function here. And then it says, wait, what? That's a terrible idea. Let's start fresh. And it rewrites it again, and it messes it up on the second time. So even LLMs can overthink, but this is kind of the process that we're going to train the LLM to do today. Generate some internal thoughts, evaluate its own thoughts, and then come up with a final response. So
I have lived out that scenario with ChatGPT so many times where like it gets it right or very close to right in the initial response, and then as we're trying to refine it to my use case, it just starts going off track, and I'm like, wait, let's backtrack. So maybe that's something they should integrate into it.
That's hilarious. That's great. And that's exactly what this paper tries to solve through DPO, but obviously it's a pretty hard problem. And so in the intro of the paper, they say how they do this is through iterative search, exploring the space of possible thoughts, and allowing the model to think without direct supervision. And Jedi Cat asked in the Discord, what is the space of possible thoughts and how are they created or encoded? And that's exactly what we're going to dive into today. And this paper really, I think, drives home the points of the Archive Dive Manifesto. If you guys haven't seen that, I'd recommend you read it. But we're very much of the opinion of not being intimidated by these big labs and trying to build this stuff on your own. This paper came out so quickly after O1, and you can tell they kind of did the work. I mean, it wasn't that complicated of a workflow, and they shot all the way up to 4th place on the Alpaca eval leaderboard with an 8 billion parameter model using these techniques, which is like competitive with some of the state-of-the-art, much larger models. So I'm excited to show you like all the steps that you'd have to do to reproduce this yourself. And Yeah, go ahead.
What you were saying, it came out quickly after '01. I kind of feel like that was their motivation. Like, oh, y'all think this is a big deal? It's actually really easy. Here you go.
Exactly. I felt the same way as I was going through the paper. Um, and so I actually took some time last night after work. I think I started at like 5 p.m. and I generated a bunch of data that followed all of these steps. And I did it all within Oxen. We have like a new feature where you can generate synthetic data. So I'll link to the data here, but you can see, and I'll walk you through the process of some initial prompts that I gathered, some thoughts that generated, had two different prompts for generating thoughts, and then also used an LLM as a judge to judge the different thoughts. And you'll kind of see each step as we walk through the process. And feel free to create an account on Oxen, and we give everybody like $10 of compute credits to try this on your own. It cost me like $2 to generate this data set last night. So feel free to burn through all of our compute that we're given for free out there. So let's start with what they call thought preference optimization, because they have to come up with a clever name for this technique. And the first thing that they kind of talk about is, why is this a hard problem? Well, there's not a ton of supervised training data for this because humans don't typically write down their internal thought process on the internet as they're solving problems. And most of the post-training data sets that you see today go directly from question to answer, and there's none of those internal thought steps. So they come up with this pipeline that they call TPO, and it looks a lot like the self-rewarding language model paper from the same team that we did a while ago, but the main difference is this block right here. So basically they take a bunch of prompts, a bunch of instructions, they run it through an LLM with a prompt that is very specific. We'll show you an example later, but it breaks it down into the thoughts and then the responses. And then you can see this area right here, they actually just judge the responses with an LLM as a judge. They don't judge the thoughts, just the responses. And then they create pairs of training data of the chosen responses and rejected responses from this judge that they feed back into this LLM to then generate more thoughts and responses. And they do this in a loop where they train the first model, have it generate a bunch of synthetic data, add that synthetic data to the training data, train a second model, train a third model, and I think they did it 4 times in this paper. So very similar to the self-rewarding language model, but with this caveat of generating thoughts in the intermediary. They break down all of the prompts into a bunch of different categories, and they observe that letting the model think through its step performs on general knowledge, marketing, and health, along with all of the typical tasks like math and coding. And they actually had a pretty handy prompt in the paper for doing that classification. So I tried it myself. And basically they said, below is an instruction that I'd like you to analyze. And then they put the instruction in kind of like an XML block. And then they say, categorize the instruction into one of the following categories. And they have like 20 different categories here between general knowledge, math and programming, etc. So what I started with last night, just to get a sense of this workflow, was a data set of 1,000 prompts. And I started by just classifying it into all the different categories. And where this is pretty helpful is like at the end of the paper, let me find this diagram, but they break down the performance per category so they can see how well this method works in math versus just like general writing tasks, etc. And they make this nice bar chart. So they say the thinking process helps the most with like research and analysis tasks, and then it seems to help the least with creative writing. But I thought that was a great way of just like prompt engineering a prompt to classify all of the data to start. And then as you're debugging and trying to see how well all of this works, you can kind of look per category at which ones it's performing the best on.
Greg, quick interruption. There's two thoughts and questions from Paul. First was, this is probably coming later, but would love to hear how this relates to prompting strategies such as tree of thought, chain of thought. And then, did performance plateau on the fourth iteration? I remember from self-rewarding language models, they stopped at 3, but without really explaining why.
Yeah, those are both great questions. So, first one, it is the prompting technique's very similar to chain of thought and like the initial tree of thought, and I'll show you the exact prompts within here. And then they do have some charts on the performance as they go through the training iterations, and I'll pull it up right here. And so on the y-axis here, you can see the win rate, and on the x-axis, you can see the training iteration. And what win rate is basically for alpaca eval, they take a bunch of prompts and run it through GPT-4o, or maybe it's just GPT-4. I forget exactly which one. And that's kind of like their baseline, is all of the responses from GPT-4. And then they use an LLM as a judge to judge the response from GPT-4 and the response from their model. So if they beat GPT-4, that's like a +1 in the win. So that's what this win rate is here. And you can see after training iteration 1, it's at like 30%, training iteration 2, 40%, and on the third one, it beats GPT-4 with this 8 billion parameter model over 50% of the time. And it does seem to like plateau a little bit after the fourth one. And they don't, I wish they would have more explanation of why they think it plateaus. But yeah, they seem to just stop at the fourth one. So I don't have the best answer there, but they do have some charts.
I know Scott said there we had to raise our hands. Sorry, I'm just raise your hand.
Dive in. Yeah.
So I think the issue here fundamentally is that we're using an LLM as a judge. And I have been thinking about that really a lot. I don't know how to say this, but it's kind of like um uh, it's risky and it's problematic. We created a system that is, and it's kind of like uh, it's it's looking into itself. I don't,
Yeah.
yeah, so it's kind of risky and problematic, and I think letting AI or LLMs making it would just undermine fundamental rights. I think humans are still more intelligent than that, and I think we have more human experience than that. So I, uh, when I read this paper, it's a fundamental human issue that I have. I'll leave it at that.
Yeah. And I totally agree with that. And I think some of their motivation around the LLM as a judge is just purely it's pretty expensive and hard for humans to go through every single one of these. Like, I'll give you some examples of the types of data that they have in here. So let's take a look at one of my favorite examples. This is like the final output from the whole process here. So this task kind of stood out to me of write a science fiction story about an advanced AI taking over the world. And so you can see the LLMs spitting out. Oh, sorry, I should probably move myself so you guys can see.
So I don't know if you saw my response in Discord, but that actually to me is kind of it. It almost seems like Jan LeCun was involved directly in that response because it's like, oh yeah, that's a common trope, and then it sets the date way in the future, like
Yeah, yeah, yeah.
2157 was it?
Exactly. It's pretty funny. So I think this is the one that I shared in the Discord. So basically, it goes through its internal thoughts. It says, okay, so the user wants a science fiction story about an advanced AI taking over the world. This is a classic trope, but I can definitely put my own spin on it, to your point. And then it makes a bulleted list of the things that it wants to talk about in here. Then it drafts a response, which I'm not going to read the whole thing, but then it evaluates its draft and says, this draft response is a good start, but it's a bit too straightforward. I want to add some complexity to the story and maybe introduce some moral ambiguity. And then finally, it drafts its final response. It puts this little delimiter so we can like split the thoughts from the actual response. And then it spits out this whole story here. And I think, if you think about us just reading this whole thing and then judging the response, it'd probably take me 10 minutes to read this whole thing, think about it, and then read another one and compare and contrast the two, and then come up with the judgment, is A or B better. So I agree with you that we're kind of leaning on LLMs to do this work, but it's also really hard to automate the testing of these things. So I don't know where exactly the balance is. It's a hard problem.
Yeah, so I just think it's ultimately, as I look at LLMs, I look at some of the responses. We're going back to human response. We're going back to human experience. Like we live lives. We're not machines. We live lives. We feel things. And I think uh, there are these aspects of humanity that LLMs can't just they just can't fathom. So I just want to leave it at that, saying that humans have human experiences, and we've had generations of human experiences. Um, there is no way an LLM could just do that. So using an LLM as a judge, um, I don't think that's the best response. I think people can write English and good grammar or fix things up, but there is a part of humanity that is fundamentally missing. So I'll leave it at that.
Yeah, I think those are all great points. I'm with you. Team human. We till the end.
Kind of, I guess, not exactly on the same lines, but I do think that if we are going to reach for LLM as a judge, and just in general before that stage, the thought generation process, I think a lot of grounding is important. I
Mhm.
mentioned before how I feel like LLM should be integrating things like NER. So just in that thought generation process, being able to stop and ask if you prompted about a specific person or thing, to be able to stop and then offload a question to DuckDuckGo, that's like, who is so and so, or what is so and so known for, to be able to feed that data into the thought process, and then for the judge to be able to check factuality.
Yeah. Yeah. So adding a couple more tools into the tool chain rather than just a prompt that's like, hey, evaluate these things. Um, yeah, totally. I think that's like an area that I think a lot of people can contribute to as well, and you don't have to be the big labs to start thinking about how to solve these problems, which is cool. Um, cool. Thanks for all those thoughts. Let's dive into the actual prompts that they use to start generating this chain of thought reasoning. And specifically, they call out two prompts within the paper. So there's a generic thought prompt, and then there's a specific thought prompt. And with both of them, they very detailed ask for a format within the response. So you can see in the generic thought process, they say, write your thoughts after a string, here are my thought process, and write your responses after a string, here is my response. So if we look at the outputs here, this was the generic, or that one was the specific one. Let's look at the generic one. So you can see, write right in here, it says, here is my response. So they're like literally using that as a split string, where all of the thoughts are above and then all of the responses below. And in the specific one, they, for some reason, decide to use a different split string character, but I just took the prompts directly from the paper. And the reason that they do that is because they just want to evaluate the raw response here and not the thoughts above it when they're doing some of this DPO work. So yeah, you can see in the second one, this must include your draft response, its evaluation, and after this, write your final response with a bracketed R. They did all of this with Llama 3.18b as well, which I thought was pretty interesting. And so that's what I ran all my experiments with as well. We talked about the crazy AI taking over the world story, so I won't dive into those anymore. But the next step after we've generated a bunch of data, given those sets of prompts, and in our case, I just generated a column of generic thoughts and a column of specific thoughts. And this is going to feed into the DPO process. So if you remember, we did a dive on DPO a while ago. Feel free to reference that for all of the like math and implementation. But at the end of the day, pretty much all you're doing is you want to generate a data set of preference data. So one response and another response, and then you're going to either have a human evaluate the responses against each other or use LLM as a judge to get a ranking of these two responses. And you'll often see in the papers, they call this step like RL from AI feedback or RL from human feedback. And DPO is like a subset of that is a little more straightforward to implement. You also hear reward model and judge model. Those are pretty similar topics. They're just the model that comes in and tries to tell which response is better than the other. So for this paper, they mention two choices for judge models. There's a self-taught evaluator, STE, which is what I did. And then there's this ARMO, RM, which I didn't check out the paper for, but might be interesting to look at as well. And for the STE, they use Llama 370b instruct and the following prompt. I actually think it'll be easier to see within here. This judge responses. So it says, please act as an impartial judge and evaluate the quality of the responses from the two AI assistants to the user question below. They give a bunch of other qualifications for how they want the LLM to judge the response. And this is an interesting caveat that they mentioned in the paper. They say that when you're doing this LLM as a judge process, there's been research to show that purely the length of the responses can influence the score. So they explicitly call out, do not let the lengths of the response influence your evaluation. But if you look at the Alpaca eval leaderboard, you'll also see there's the LC win rate, which stands for that length constrained win rate, and then there's the regular win rate. So if you ever see this LC, it's because they're normalizing for the length of the response and not just letting the LLM be biased against the length of the response. And then they basically put in the user question here, and then they have a delimiter for the start of assistant A's answer, and they put in one of the responses, and then the start of assistant B's, and they put in the other. And they say output your final verdict by strictly following this format. So you can see the final column that I generated here was the judgment, whether A or B is the better response. And you can also see in this data set, I split out the thoughts themselves from the response based off of that delimiter that we saw in the middle. So in this case, it was here's my thought process, and then here's my response was the delimiter. And we're just putting in the thought response, not the thoughts above, just the response for this LLM as a judge. So that's concretely what that step looks like. And then this creates training data pairs for the DPO step. They get a little more involved in the paper than just 2 pairs. So specifically, let me find the numbers there, but they say they generate 8 responses per prompt using a temperature of 0.8 and a top P of 0.95. And this way, you not only have like an A and a B that you're comparing, but they actually take all of those responses per prompt, and they convert the individual point-wise scores into an ELO score. So similar to like a chess ranking score, they have a bunch of pairwise judgments, and to figure out which one is the best and which one is the worst, they make this big matrix of all the scores and compute an ELO score. If ELO score is confusing, this was pretty clever. At the end of the paper, they add in, they test the LLM that they trained, and they say, write a program to compute the ELO scores of a chess tournament. And you can see it goes through its internal thoughts, it drafts a response, it evaluates the draft, and then it writes Python code to calculate the ELO score. So I thought that was like a clever dogfooding of their own process with the final output of the LLM. And what's more, they say that the baseline LLM without TPO fails to answer the question above. So if it doesn't do its internal thoughts, drafting the response, evaluating the draft, and then generating the code, it wasn't able to successfully make an ELO rating calculator, which I thought was interesting. Once they have all the ELO scores for each one of the preference pairs, they then select the highest and lowest scores and construct the pairs from that. So like in my example that I did before, we just had 2. So if you wanted to turn that into DPO data, you could just take those 2. But instead, they take 8, and then they take the one with the highest score and the one with the lowest score and use those as pairs so that there's more likelihood that you have a really good example and a really bad example, and not 2 that are really close to each other.
So I would love to see how this works on, I don't know if you're familiar with RWKV, Rokov, the parallelizable RNN model. So BlinkDL, the principal author and the primary developer of Rokov, has been promoting a lot of extreme COT on Rokov because it's all just linear. With, I guess, either the Finch model, Rokov 6, or the upcoming Rokov 7. And he's like, yeah, it's because of its nature, it's great for extremely long COT processes. So I would love to see how that trains through this sort of process.
Oh, that's cool. Yeah, we should definitely take the outputs from here, put it into a DPO format, and then do they have a DPO trainer for this? Do you know?
That I'm not sure, but I mean, there is I know it's not, I guess the training's not as good as using the actual, like they have an infinite context trainer But it's its own format. But I know they do have Transformers, Hugging Face Transformers compatible models.
Okay, cool. I know there's a really nice DPO module for Hugging Face transformers. So if that plugged in well, that might just work. That'd be fun to try. Cool. Love that call out. I actually haven't tried any of the Archive models, but I hear about them all the time.
Are there any models you would like us to try? We can try them.
I mean, this is a great start. I also saw there was like a small LM that was released by Hugging Face today that was pretty cool. I can
They're
find
doing
that
a
link
lot of
after this.
they're doing a lot of fuse stuff on a typical GPT style or llama style transformer, right? Like
Yeah,
I think
yeah, I
they're
think
they're
so.
fusing like the norm with the inputs and stuff like that.
Yeah, as far as I know. Uh, Sounds right. But yeah, let us know if you guys do try any. Happy to keep working on some of this training data and then just post it in the Discord if you do
Greg,
try on any of these models.
so I am a user of Oxen AI. I did log in, but I'm not sure what kind of data to put in. For the following reason, I think there's copyright issues, and we live in the United States, and there are people with copyright issues, and I was looking at a lot of music data. So if there is some, I guess, disclaimers, and you can tell us like what kind of data can we put in? I know there was something about um athletes and things like that, which is exciting, but I'm just a little concerned about like copyright issues with data. I think that has happened to people in the past, and it's not a huge concern, but I just want to make sure that I'm methodical about it.
Yeah, I think definitely if the data set does have a license in it, look for like the Creative Commons license and what the reshareability and remixing of it is. That's usually the place that I start. Um, but other than that, it is kind of like a fuzzy gray area, and I like that you're cognizant about it before uploading it to our service where we might have to take it down.
This is this is also a big reason why I warn people about like as much as I love Meta's work, their licensing leaves a lot to be desired.
Yeah,
And things like anything out of new or news research because it's all generated from black box models.
right. Yeah, and that's another thing to keep in mind. Like we have, in oh, I must have gone out of that tab. I'll show you guys. But like for this data set, you can kind of go in here and click this rocket ship, and we have a bunch of different providers and a bunch of different models within here. But you have to kind of be careful with, you know, OpenAI has different terms of service than Together that may provide the llama models, etc. So just be cognizant of that as you're creating synthetic data.
May I ask a question?
Yeah.
I'm assuming that because there's an iterative approach to training the model in order to actually get the thinking process working, that it wouldn't be possible to do this just as an adapter, like an Alora on top of a model.
You could. I think it might not have the same performance as a full fine tuning, but we did actually do the self rewarding language models, I think like 6 months ago when that paper came out, and we didn't have enough VRAM to do the full fine tuning. So we just did a LoRa and then combined those weights directly into the model on each iteration. That was before these models were that good. So we tried it on like Mistral 7B and we saw the performance degrade pretty quickly there. But I think with these newer Llama models, especially the 3.18B, I think you could totally try with the LoRa, merge it back in, and see how it performs.
Nice. Thank you.
There was it's been, I want to say it's been over a year now. There was a paper that came out called Relora, or the technique was called Relora. And I know there were some sticking points that people had issues with, like they used a jagged learning rate scheduler. But what it basically does is does a LoRa run, merges it, resets the learning rate, does another LoRa, merges it, and is basically conceived as an alternative to almost, basically as a way to almost completely replace retraining. But I don't see why it couldn't work for, fine tuning as well.
Yeah. What was that called again?
I can't remember. I think the paper is called Stack More Layers Differently or something like that. But the technique is called RE, LoRa. That's it.
It is. Yeah. Cool. I will link to this in the Notion as well. Cool. Those are great questions. It looked like there was a Git up there too.
Mm-hmm. And there was one of the more recent papers that used like I think they used like a low rank gradients and maybe like 8-bit or 4-bit gradients. Dora, I don't know. There are so many now just branching off of that name, but they integrated the Relora technique to really accelerate things.
Cool. Yeah, I haven't looked too deep into that one. That's a good tip. Cool. So yeah, they do this in the loop. One thing that they did note that I think would be interesting if you want to do this retraining is they say for each round of training, they start with the new model that they trained in the last round, but they throw out the old data. So they're not just like appending it to the data set. And each data set that they create at each iteration, I think, is 5,000 examples. So it's not a huge data set either. And very doable, I think, on your own hardware or your own data set. And this is where it gets pretty interesting, is here are the results, both on that alpaca eval with the length constrained and on arena hard, which I didn't look too deeply into. But if you look at the alpaca eval leaderboard, the top model here is GPT-4 Omni, and it has a win rate of 57%. And you can see the baseline is GPT-4 Preview. So that's what I was trying to think of before, is what model are they comparing it against? And so there's only like 5 models that have a higher win rate against GPT-4 Preview, and a lot of them are the subsequent releases of GPT-4, and there's this E model right in here. But the Thinking LLMs hops right into that mix with 52% win rate, and it's an 8 billion parameter model that they started with. So pretty impressive that they hopped that high on the leaderboard with such a small model. And what's interesting about this as well is the base model got like 24%, and then the base model plus just the thought prompt that we put above was actually, the performance dropped if you just added that thought prompt. Then when you add multiple thought prompts, separate the thoughts from the responses, compare just the responses, and feed that back into DPO, that's where you get the big boost in performance. So kind of blows my mind that it actually goes down in performance with just one thought prompt and response. But when you're able to like generate a bunch of options, pick the best one, and then do DPO on it again, it's kind of like navigating that search space that we talked about above, of how do you get the right thoughts and not have human labelers for all of these things. So pretty impressive. And they list some other larger models, and how they don't even get over 30s on this task.
Hey, Greg, with Grok, Elon, with Twitter's Grok, one thing I've noticed that's consistent kind of with that is the Grok. I'm getting so much better results with Grok Mini than the larger Grok that you have to manually switch to for image captioning. It's like night and day. Like Grok Mini is completely correct and Grok Large is completely wrong with what I need to write it up and jot a note to Elon about it.
That's really interesting. And then so Grok Mini probably got released after Grok Large, I would guess. Yeah.
Yeah.
Because I wonder if they just, got better training data for that second set of release. But yeah, I think there is a little shift in the narrative of like larger is all you need. I think, we clearly see the shift into better training data curation is what you need. Cool. That's interesting. Yeah. If you write up any results there, share it with us because I'd be curious to see that as well.
Yeah, I was going to drop an Oxen AI tag in my note to Elon for sure.
Love it.
Just in case he replies.
Just in case. You never know. That man is always on his own platform. All right. Cool. So that was kind of the results section. They do note in the results section that it didn't perform as well on the math category as they wanted it to, but then they took a closer look at the data and they said only 2.2% of the training instructions were categorized into math from that like 5,000 prompt set that they had. So I think, again, that's just like a data distribution issue. And if they wanted it to get better at math reasoning, you should bump up that kind of graph that we saw before and balance out the number of training examples in math and reasoning. This is kind of hard to...
That's another scenario where I feel like grounding would be an easy win for that. Just tool use of,
calculators and stuff like that. Yeah, totally. I think math and programming would definitely two categories that would help from that and not just the generic judge. So yeah, that's kind of the main takeaway of the paper is generate synthetic data, use LLM as a judge to evaluate that synthetic data. And like with all this hype around O1, in the spirit of archive dives, I'd love to see if people can recreate O1 at home with their own data. And like I said, it cost me like $2 to generate that data that I was looking at last night. It'd probably take less than $10 to get 5,000 examples going and kick off the process, and might be a fun little weekend project for me here over the weekend, or if anybody else wants to join in.
I'm gonna say I've had that as a pet project since O1 came out. Basically, I wanted to see if I could get like the best performing local version of it. So I've been like collecting other papers, but this one is a pretty good putting all those together. So if you end up doing that in like Discord or something over the weekend, then I'll probably stop by.
Awesome. Yeah. Hit me up in the Discord and let's try to collaborate on it. Cool.
The
Sounds
plus
good.
side, this model won't send you a nasty email if you ask it for a reasoning trace.
That was the other thing I was going to mention is, then we can actually look at the thought process as it's coming out and not just have the summaries from them. I do think it's an interesting, like, debugging or, how do you want to say it? Like, understanding a little behind why they might come to the decision rather than just spitting out the answer. If you do have that thought trace, then if you're doing like a legal case or something like that, you might be able to have a little insight into why it made the decision. But again, it is still a little black boxy.
No, not at all. So, Greg, oh, sorry, did I speak out of line? Just double checking.
No, come on. We love all thoughts.
We love thoughts. So, in 2013, I was one of the first people to create AI in the drug, sorry, in pharmaceuticals. I want to make sure I get my words correct in pharmaceuticals and
Non-recreational pharmacy.
yeah, in medicine.
Nice.
He gets me in medicinal pharmacy in medicinal pharmaceuticals, and we were looking at cancer. So I mean, it was a Markov chain Monte Carlo simulation, and it started like 10 years ago. And a lot of this was I created a lot of synthetic data like several years ago, and some guy in Google called me up and he said, "You have to visit me in this YouTube building." And he said, "Did you hallucinate all these data?" Like I was sorry, I was just like terrified. I couldn't even speak to him. Um, yeah, but um, uh, having said that, a lot of this data that I think would the reason I love coming to Oxen AI dives is that you guys are talking about data and how to use it. And I really believe in it. I don't know how else to say it. I'm not an angry person, but
No, we believe right there with you. And some of these are pretty deep philosophical debates as well. So we're happy to have people bring them up.
Shalini, I don't think anyone would confuse you with an angry person. Just FYI, just in case you need that.
You're the cheeriest person I know, Shalini.
Affirmation, yeah. Darn it, she's grumpy again.
Oh man. All right, I'm gonna kill the recording here, and we can jam a little more offline if you guys want to. But thanks for joining, you guys. Join the Discord. Help create O1 at home with us if you want. We're gonna be hacking on it. So thanks for showing up, guys.